Okay, yesterday in science we started talking about the scientific method or the scientific process. What was the first step in the scientific process that scientists use to perform any experiments or to do any kind of observations? First thing I do is ask a question. What are they trying to find out? And yesterday we used the example of dropping the ball. Which ball will drop the fastest, right? That was the question. That was our first initial question. What do scientists need to do after they come up with their question? Yes, sir.
Look up information.
Yeah, they got to do some research, look up the information. If somebody's already done it, do the scientists need to go and do it again? No. Okay. Sometimes they need to go and look up some scientific principles. Yesterday, when we were dropping the ball, what was the scientific principle that we had to go do a little research on? Yes, ma'am.
What they are made
Okay, we could have done what they were made of, but what was it that we're talking about? What was the scientific principle when we're talking about the balls dropping? Yes, sir.
of. Their weight.
What?
Their weight.
Not their weight.
Gravity.
The gravity. Gravity is the scientific principle. What causes them to fall down? It's the gravity. So we needed to go do a little research on gravity. Then, what does a scientist do? They come up with a question, they do a little research, and then what do? Wake up. Come on. Somebody knew. Yes, ma'am. Come up with a hypothesis, which is a prediction, right? We decided yesterday, a lot of people were picking, I think the big ball was going to drop the fastest, the heaviest ball, the smallest ball. We came up with all of our different predictions, okay? So today, we are going to move to the next step. Once a scientist has figured out, they have a question, an inquiry, a wondering kind of statement, and then they do a little research, and they figure out which one they think is going to be the best or whatever, the next thing they got to do is actually design that experiment. And when I mean design the experiment, that means how are we going to do this? Okay? This is just like a recipe. How are you going to make bread? What do you need in order to make bread? Before you can just start making bread, you have two things that you need to figure out. What do you need to figure out when it comes to making bread? Yeah, you need all the ingredients, right? I need flour and sugar and eggs and milk and whatever else it is. I need all my ingredients. What else do you need to know to make bread? Yes, ma'am. Okay, that's part of the ingredients. How much, what kind, all that kind of stuff. All my ingredients. What else?
How long do you have to bake it for?
Okay, I need the directions, right? How do I put it together? How long do I bake it? Those are your directions. So when it comes to a recipe, you have all of your ingredients and you have all of your directions, right? Well, when it comes to science, we don't call them ingredients and directions. What do we call them? Who remembers? In a science experiment, what are all of our ingredients? All the things we need. Yep.
Materials.
Your materials, and we don't call them the directions. What do we call them in science? Not instructions, but close. They're called your procedures. Procedures means that's your big fancy science word for your directions, your instructions, okay? So in science, you need to be able to tell them exactly what they need, and you need to be able to tell them how to do it. What happens if a scientist does not give good materials? What if they just said, hey, I found the cure for cancer. All you need is a lemon, some sand, and a stick. Is that going to work very good? No. Why does a scientist need to have very, very, very good detailed materials? Why do they need to put the right material? Okay, let me go back to recipes. Why, in a recipe, they tell you, I need 2 eggs, I need 1 cup of sugar, I need 3 cups of flour, right? What if they just said, get some flour, sugar, and eggs? Will that work? Why not? You don't know how much. What happens if you put 8 cups of sugar and 1 egg in there? Are you going to make bread? Are you going to make the same bread that is in the picture? No. Science is the same thing. if you do not put the right materials in there, you're not going to come up with the same results that somebody else has already done. So a scientist has to be very, very detailed. What about the directions? When you read a recipe, does your recipe say, mix it all together and put it in the oven? Yay, I'm done. Does that work? Why is that not going to work? Yes, ma'am. You need to know how long. What if I put it in there and I say, you know what, I'm going to mix it up and I'm going to put it in the oven for 8 hours. Are you going to get the same bread as what's in the picture? It may be burned. What else? What else could happen if you do not put good details in your procedures or your instructions? Maybe you're not supposed to mix this one with that. Maybe you're supposed to put the temperature at 300 degrees, not 500 degrees. Okay? So a scientist has to be very, very detailed. Now, let me ask you this. Is there anybody in here, is there anybody who cannot make a peanut butter and jelly sandwich? Everybody knows how? I'm hoping I picked something that everybody can do. Everybody can make a peanut butter and jelly sandwich. Perfect. You, for your homework, due Friday, is going to be make a peanut butter and jelly sandwich. Actually, you're going to tell me how to make it. Pretty simple, right? What 2 things am I going to be looking for when it comes to making a peanut butter and jelly sandwich? Yes, sir.
Peanut butter and jelly.
No.
Material?
The materials. What do I need to make a peanut butter and jelly sandwich? Okay? So I need a list, just like a recipe. I need a list of all of my ingredients to make a peanut butter and jelly sandwich. Everything, every single possible material to make a peanut butter and jelly sandwich. What else do I need to make peanut butter? What else do you need in your assignment? No, don't give me a list. What else do you need? Your procedures. So you are going to give me the list of materials to make a peanut butter and jelly sandwich and your procedures. Now, you have to be detailed. If you are not detailed, it's not going to work. Pretend like I'm from a different planet. I've never heard of peanut butter and jelly sandwich. You need to tell me how to make peanut butter and jelly sandwich. You need to list exactly how all of your materials, and you need to list and go into very good details on how to make that sandwich. Okay? Everybody understand what your assignment's going to be? It's an easy 100, right? So if you can write your materials and your procedures, and I can make a peanut butter and jelly sandwich out of your list, you got 100. Pretty simple, right? We'll see. This is going to be your challenge. It's due Friday. Back to our scientific method. After the scientist comes up with the materials and the procedures, they do it. Okay? I'm going to learn how to do my experiment, do it all, my materials, my procedures, and I'm going to actually do it. While they're doing their experiment, what are they doing? What is a scientist doing when they are actually doing the experiment? Do they do the experiment and say, have fun, watch this? What is a scientist doing? They're keeping track of it. What are they doing? They're actually analyzing their data, their results. Okay, they're gathering their data. They're figuring out, okay, well, this one was that, and that one was this, and they're writing it down, writing everything down. And what do they write it down in? They put it in a data table and a graph. Okay, so I'm going to show you here in a minute. You're going to take a data table, you're going to take all your information, your data, and you're going to put it into a graph so that you can look at this graph and analyze it better. Okay? Once a scientist has finished doing his experiment, he's graphed all of his data and he's got everything figured out, what's the very last thing a scientist will do? Okay, he'll sit back and at the very end he'll write it all down. He'll come up with his conclusion. He's going to draw a conclusion. He's going to try to figure out, okay, after doing all this experiment, what did we figure out? Okay, so yesterday we dropped those balls, right? We said which ball will drop the fastest. We did a little research on gravity. Most of you did a hypothesis. I think the heavier ball is going to drop fastest. And then we actually did the procedure, right? We actually started dropping the stuff. At the very end, we drew a conclusion. What did we kind of figure out? After doing that whole experiment, what did you figure out? That all balls will drop at the same time, right? They all drop the same because gravity is the same. So when you sit back and you analyze or draw your conclusion, what are you actually doing? First thing you do is, was your hypothesis correct? How many of you had the right hypothesis yesterday? 2 of you. How many of you had an incorrect hypothesis yesterday? Does that mean you're wrong? No. If your hypothesis is wrong, that's okay. So, was your hypothesis right or wrong? What did we learn? Well, we learned that when you drop balls at the same height at the same time, they fall at the same speed because gravity is the same, right? Last thing, if you were going to do this again, what would you do differently? What would you change? So what would we do next time? If we were going to do this again, does gravity affect these balls? What would we do? Would we just say, well, I'd change the balls? No, because that's what we just did, right? What would be something we could do differently? Yes, ma'am. Real loud. Mask is on. No, we're not going to change the hypothesis. I'm talking about changing your whole experiment. Instead of dropping the balls, we did that. What would I slightly tweak? What could we do? Maybe drop them at a higher height. Maybe if I drop them from like a 5-story building, maybe they'll start building up speed and one will go faster than the other. Could be. That's something we could try. What else could we try? Next time, what else could we try? Yes, ma'am. Different what? Not different research. It's going to be the same. What else could we try next time? Okay, maybe I'll say, wait, let's try the bouncy balls and see which one will bounce the higher. Okay, that's something we could try the next time. All right? So your steps. This is very important that you know your scientific method because starting tomorrow, I'm going to give you a lab to do on your own, and you're going to have to do all of this stuff. Okay?